Okay, so this is what your number 9 should look like. I went ahead and finished all of the problems so you can see all the answers. But what I'm going to have you do right now is we're actually going to add 2 things to each problem. So starting with number 9, I want you to also write the range, which in this case is 0 and higher. So y is greater than or equal to 0. And then now we're going to write a comparison. So we're going to compare this to the graph of y equals square root x. So if I have y equals the square root of x, I'm going to remember that this graph looks something like this. Okay? Starts at 0 and it kind of goes up like that. Okay? That's the general shape of y equals square root x. And so if I'm comparing this to this, I'm going to notice that this one, if I have a number in front, this 5, means that it's going up 5 times faster. Okay? And that's something I'm going to say, is that it increases faster by a ratio of 5. That's exactly what you're going to right there. Or I guess ratio is the wrong word, sorry. Should be a factor of 5. So it increases faster by a factor of 5, okay? So that's what we're going to say there. So notice that if you put a number in front, things go up faster, right? We're increasing faster. All right, let's do the same thing for number 10. Number 10, we're going to talk about the y value. So if I'm zeroing in on the starting point, I'm noticing that the lowest y value possible here is 1, and it goes up from there, right? We increase as we follow the graph. It increases in the y values. So it's y is greater than or equal to 1. Now the comparison for this one, notice that we have a plus 1 here at the end. And so if we're comparing it to the original graph, we notice that it didn't start at 0, it started at 1. So all that happened here is it just shifted up 1. So all we're going to say for this one is it moves up 1 unit. That's all you're going to say for number 10. Okay? Let's look at number 11. Number 11 looks like this. So your graph should look like this, where it starts at 2 and it kind of looks like normal. Okay, so something else is going on here. So first off, let's talk about the range. The range starts at 0, right? The y value is 0 right here, and it's going up. So it's greater than or equal to 0. Now let's look at the comparison. So the original graph started over here, but now it's starting over here. But it's the same exact shape. Nothing else changed. Notice that the only thing that changed about the equation was the minus 2. This seems to be working just like quadratics, where if I have a minus 2 on the inside here, it's actually moving to the right. So just like absolute values, just like quadratics, these also do the opposite of what you would think for the x values, because it's on the inside here. So for this one, you're going to say moves to the right 2 units. Okay, that's what you're going to write for this one. All right, let's look at number 12. If I'm going pretty fast, it's because you should already have all this stuff done. Everything that I have already written down, you should also already have written down. If you don't have it written down, or have at least tried all these problems, then you should have tried them ahead of time, okay? Should have at least attempted them, at least have the graphs written down. Even if the graphs are wrong, that's okay. As long as if you attempt them, you should have some kind of graph on your paper right now. You can go back and re-edit these if you need to. These videos will be in Google Classroom, so you'll be able to rewatch them if you need to. So let's go ahead and look at this one. So now we've got two things happening here. So first off, let's talk about the y values. The y values, once again, are starting at 0, and they're going up from there. So nothing changed about the y values. But something strange happened with the x values. So notice that in our domain, now we're moving to the left and we're starting at -1. So something strange happened here. I subtracted 1, and instead of going to the right 1 unit like I did in this last one, I actually went to the left, and there's a reason why, and it's because of this negative right here. So whenever you have a negative out front of here, two things happen. One, let's actually kind of pretend like the negative's not there. So if the negative's not there, what would our graph actually look like? Well, I'll draw it in pencil. You might want to do this as well. Draw like a light version of this. Well, it's going to look something like this. It's going to move 1 unit to the right, and then it's going to generally look something like this, right? It's going to look really similar to this graph. So if there was no negative here, in fact, you can kind of write that in here. There's no negative here, right? So notice that it does that, but then something else happens. When we add the negative in there, what happened? This didn't move to the left. It actually reflected perfectly over the y-axis. So this is a reflection. This is like taking this entire thing and flipping it, and now it's over here. You guys see that? How this is a reflection of this. Now I didn't draw the graph super nice. It would be up a little bit more if it was accurate to this graph, but this should be a perfect reflection over here. So the two things that we're going to say in the comparison, and I kind of covered up my comparison, so that's not great, but I'll write it nice and small, is the first thing that happened is we actually moved, we did move to the right, but we need to say that first and then say what happens after moving to the right. Well, it reflects over the y-axis. So it moves right 1 unit, then reflects over y-axis. Okay? That's what we're going to write right there. We're going to write it moves 1 unit right, because it technically does. If it's supposed to look like this, then it moves to the right 1 unit, and then the next thing is it reflects over the y-axis, and that's how it ends up on the left after the reflection, right? So if you're giving someone directions, let me give you an example. If you're giving someone directions and someone is facing a certain direction, let's say I'm facing this direction, and I need to turn right, but I accidentally turn left. Now, one way that I can reroute is I can turn left again and then turn left again. Notice how now that sends me going to the right, right? So it's kind of like the same idea as you can mess around with the directions, you can mess around with reflections to actually get you to go the right direction. So even though I did move to the right, but I wanted to go to the left, I could say I go to the right and then I reflect, and that puts me in the direction to the left. If you don't understand that yet, just copy and paste this idea into your homework whenever you see a problem like this. Look back at your notes, see what you wrote down for this, and try and see if you can mimic this problem for now. And then eventually you'll start to click. Eventually you'll start to understand this a little bit more. Okay? So let's move on to number 13. We're almost done. So number 13, our y value, or our range, once again, is all the y values 0 and above. So y is greater than or equal to 0. We start at 0 and we're moving up, okay? And then the comparison here, there's two things happening. So once again, I have another strange case where I'm starting here and now I'm going to the left. How many units? 4 units. So 4 units to the left, so moves 4 units, and we'll say left, and then there's a second direction that happens. After you move 4 units to the left, what's happening? We've got this value in front again. Last time we saw that, it was on number 9 when we had 5 in front. So this time we're going to say the same thing, increases faster by a factor of, in this case, it's 2. So increase is faster by a factor of 2. Okay? So it's going up twice as fast. That's kind of what you're saying there. So it moves up moves left 4 units, increases faster by a factor of 2. That's what you're going to write there. Notice that you're always including the numbers that are written in here. Okay? Let's move on to the last one. This one's kind of got a lot going on with it. So let's try and take each part one step at a time. So first off, notice that the y value isn't changed in this one. We still have y is greater than or equal to 0. That's kind of nice. All right, so what we're going to do here is we are going to take each piece. So first off, we notice that we have a plus 2. Right now it's going to the right, but last time we had a plus, we said we were going to the left. So rather than looking at the graph, let's just trust what we said before. It's actually going to go 2 units to the left. And notice how I've already written in some of the points for the imaginary line. This was kind of how I was processing it earlier. You can kind of see the imaginary reflection right there, as if the negative wasn't there, right? So this imaginary one would be the same thing without the negative on the x, right? So if we're not putting a negative in front of the x, it looks just like this. So we're going 2 units left. Our next direction is after I've gone 2 units to the left. I am now reflect across y axis, and then finally, now instead of going faster, if there's a fraction in front, I'm actually going increases slower by a factor of, instead of saying 1/2, you're going to say it's slower, so it's 2 times slower, right? It's twice as slow. You're not going to say it's half as slow. Half as slow would be a faster rate. So it's increasing slower by a factor of 2. So this 2 relates to the 1/2, okay? That's what's going on here. All right, let me look at your homework to make sure we've covered everything that might be important. One more kind of side note that I think would be important to look at is, let's go ahead and go back to number 8 real quick. And this is going to be a really quick note before you work on the homework. Let's look at number 8, and let's notice that here we have a negative number. In fact, this would be, highlighter would be good for a lot of this. But let's notice that when you have a negative number out front, when the number is negative, it's kind of like the same idea with quadratics. It makes everything go upside down. Or in other words, you actually do a reflection across the x-axis. Okay? So that's a note that I would add to this, is notice that it's reflecting across the x-axis if you have a negative right here. Okay? It's an important note to look at when you're doing your homework. Okay, what I want you to do is go ahead and work on 10.1 practice. It should be available on my desk. Go ahead and skip number 8, and we'll work on number 8 together as a class tomorrow when I return. All right, see you then.